So we're going to be looking at today how to calculate what's called OR probability. So it's probability of compound events, meaning more than one thing happening. And if I want one thing or the other thing to happen, how we figure out the probability of that occurring. Okay. For example, if I was pulling out a card from a 52 card deck of cards, right, and I want to figure out what's the probability I get a hearts or a 7, for example, right? So two different things are happening, one or the other can occur. I spin a spinner and I need either a 5 or an even number, something like that. So looking at that. Now, when this occurs, there's a couple things that might happen, okay? We might have what's called disjoint events. Disjoint, okay? Another term you might hear get used is mutually exclusive. Okay, I like the term disjoint better because I think it intuitively makes a little more sense. But you think about like a joint, like your elbow is a joint. It's where the two parts of your arm meet, right? The word dis in front of a word typically means like the opposite of or not that. So disjoint events are events that don't have any overlap. They don't have any connection, okay? And I'll give you some examples here in a second. So that's a disjoint event, okay? If there is events that or things that two events share, we call this overlapping. Sometimes you might hear not mutually exclusive. For example, if I pull a card out of a deck and I want to get my two things are getting a hearts or an ace, well, the ace of hearts would fall under both categories. So we'd say that that card is an overlap of the two. Okay, and we'll do a couple examples here to show you what I mean here. But again, you can either have disjoint events or you can have overlapping events. Disjoint, they don't have anything in common. Overlapping, the two events share things. Okay. Oops, wrong screen. Let's go. There we go. Okay, so let's look at a couple examples here. It says you're randomly choosing a number from 1 to 20. Okay, so you might put them on a slip of paper, throw them in a hat, whatever. For the specified events A and B, tell whether the events are disjoint or overlapping, then find the probability of A or B. Okay, I'm going to actually start with the second one here first. So I'll start with this one here. It says event A is choose a number divisible by 12. Event B is choose a number divisible by 5, right? So if I think about that, numbers 1 to 20, the only number divisible by 12 would be 12, right? Choose a number divisible by 5, well, that would be 5, 10, 15, and 20. So that's 4 of them, right? So individually, I'm going to write their probabilities, okay? So there's only one number out of the 20, excuse me, that is divisible by 12. So I'd say I'd have a 1 out of 20 chance, okay? All right, of that, and we're going to call that event A. So the probability of A would equal 1/20th. Okay, the probability of B, okay, and event B is choose a number divisible by 5 would be 4 out of 20. Okay. Now what I want to do is I want to find the probability of A or B, right? And if you think about it logically, right, I want to know what's the probability of picking one of those 5 numbers. Okay, maybe I'm playing a game, and if I get one of those 5, I win the game, something like that. So there are 5 different things that fall into that category. And if I think about my two probabilities, well, what do I do with 1/20th and 4/20th to get 5/20ths? Okay, I simply add them. Okay, so for disjoint events, these are disjoint, there's no overlap. Okay, I simply go the probability of A or B. I'm just going to add their probabilities. It's the probability of A plus the probability of B. Okay, so if I just add those together, 1/20th and 4/20ths would be 5/20ths, which simplifies to 1/4. All right, so the probability of getting a number either divisible by 12 or divisible by 5 is 5 out of the 20, simplifies down to 1/4. So I'm just going to find the individual probabilities. I'm going to add them together. Okay, pretty simple. Now, let me clear this here. If I look at the first scenario, the eraser's being a little slow. There we go. It says Again, same idea. We want to figure out if they're disjoint or overlapping and then find the probability of A or B. So it says event A, choose a number divisible by 5. Okay, well we already did that once. That's 5, 10, 15, 20. Okay. And we want to choose a number divisible by 3. Well, that's 3, 6, 9, 12, 15, and 18. Okay? So I know the probability of A or B happening. All right, so again, kind of think of it like a game. If I was playing a game and I needed a multiple of 5 or a multiple of 3 to win, what's the probability of that happening? So again, we're going to take the probability of A here, which is 4 out of 20. And we're going to add the probability of B, which is 1, 2, 3, 4, 6 out of 20. Okay. Now, this one we have to keep going. Again, these are overlapping events. Overlapping events because we've got some things that occur twice, right? If I take a look, the number 15 appears in both lists, right? So if I count 4 and then I count 6, right, I'm really counting the 15 twice, and I only need to count it once. So what I need to do is I need to subtract one of those. So I'm going to take away, and we call this the probability of A and B. Okay, which is, which is 1 out of 20. Okay, there's one that they both have in common. So 4/20 plus 6/20 minus 1/20 gets us 9/20. Right? And again, if I count those 1, 2, 3, 4, 5, 6, 7, 8, I've already counted the 15, don't count it again, 9. So we can see that we have a 9 out of 20 chance. So basically, I want to add the two probabilities. So I do the probability of A plus the probability of B. Okay, and I subtract the probability of the ones that are in both. Okay, so add them up. We just with overlapping events, we have to subtract that overlap. Okay. All right. The last thing we're going to look at here is a special type of disjoint events, and those are called complements. Okay, complement. So essentially, in probability, the complement is that event not happening. So if I have the probability of an event, probability of A, the complement would be the probability of whatever A is not happening. So the probability of not A. Right? So if I was finding what's the probability of rolling a number cube and getting a 5, its complement would be what's the probability of rolling a number cube and not getting a 5. So typically if you stick the word not in front of the event, that gives you your complement. Okay? And if we think about it, really those are the two options. You're either going to roll a 5 or you're not going to roll a 5. You can't kind of have anything in between, right? I can either win the lottery or not win the lottery. So if I said what's the probability of winning the lottery, the complement would be what's the probability of not winning the lottery. Those two things are always going to add up to 1 or 100%. Okay? Probability of rain's 20%. The probability of it not raining would be 80. All right? So I just got 3 examples here. If it said given the probability of A, find the probability of not A. So that's the complement of the event. So if the probability of event A is 44%, its complement would just be subtracting from 100%, so that would be 56%. Okay, probability of A is 44, the probability of not A would equal that. Okay, 0.01, I just subtract that from 1, and I would get 0.99. Okay, as a fraction, I just do 1 minus 6/7, so the probability of all these complements, okay, would equal that. Again, a probability and its complement together always add up to 1 or 100% if you're doing a percent. Okay, it's pretty simple.